Everything happens for a reason, and that reason is usually physics. Good day, all. Today we are going to be talking about chemical bonding. It's a force that holds atoms together to create a single unit. This single unit is often referred to as a molecule. Their atoms either bond by sharing electrons or transferred electrons. Atoms do this to have a more stable distribution of electrons that correspond with the nearest noble gas. One expectation to bonding is noble gases that are monoatomic, meaning that they have an atom per one molecule. Under chemical bonds, you get intramolecular bonds that are the force that hold atoms together within a molecule. Intermolecular forces are forces that exist between molecules. There are three types, which include covalent, ionic, and metallic bonds. Covalent bonds. When two atoms bond together by sharing one or more pairs of electrons, a covalent bond takes place between two or more nonmetals of the same element or different atoms of the same element. When atoms bond covalently, a molecule is formed. This is held together by a shared electron pair. Now that you understand what covalent bonds are, there are three types of covalent bonds: molecules of an element, molecules of compounds, and covalent network structures. Molecules of an element. Firstly, single covalent bonds. A single covalent bond is formed when each atom has to share one electron to gain a noble gas structure, which is what they strive to resemble. In a single structure, two electrons, one pair, are shared to form a bond. Secondly, double covalent bonds. A double covalent bond is when two half-filled orbitals of two atoms overlap. Thus, the atom of the element shares two electrons. Thirdly, triple covalent bonds. A triple covalent bond is half-filled orbitals of two atoms that overlap with each other. Thus, the atoms of the elements share 3 electrons. The molecules of compounds. In covalent bonds, there is also two types of bonds, namely polar and nonpolar bonds. Polar covalent bonds are usually formed between two nonmetal atoms having different electronegativities. A nonpolar covalent bond is a bond in which the electron pair is shared equally between the two bonded atoms. Properties of simple covalent substances. Low melting and boiling points because molecules aren't bonded to each other, but only loosely held together. They are easily separated. For example, nitrogen has a BP of negative 183 degrees Celsius. High volatile, high tendency of a substance to vaporize. Insulators, they aren't free charge carriers. Giant covalent network structures. These occur when a nonmetal atom forms covalent bonds with more than one other nonmetal atom. This allows a giant covalent lattices to form. Each carbon is bonded to 4 other carbon atoms. Example 1, diamond. 1. Hard. Many strong covalent bonds holding the structure together, making it a very strong crystal. 2. Very high melting point. Many strong covalent bonds hold the structure together. It requires a massive amount of energy to pull it apart. 3. Insulator. All of the valence electrons are used in bonding. None of the electrons are free to move. Example 2. Graphite. Each carbon is bonded to 3 other atoms to form a layer. Properties. 1. The bonds between the layers are weak, and thus the layers can slide over each other, making graphite slippery and can be used as a lubricant. 2. Because only 3 electrons out 4 valence electrons are. Example 3. Silicon dioxide. Silicon dioxide, also called silica. Many precious gems contain silica. There are no discrete silicon dioxide units. Every silicon is bonded to 2 oxygen atoms. 2. Ionic bonding. Ionic bonds are the electrostatic force of attraction which holds the 2 oppositely charged ions together. This kind of bond is formed when one atom gains electrons, while the other atom loses electrons from its outermost level or orbit. The bond formed by this kind of combination is known as an ionic bond or electrovalent bond. Chlorine is a diatomic molecule, and so for it to take part in ionic bonding, it must first break up into 2 atoms of chlorine. Sodium is part of a metallic lattice, and the individual atoms must first break apart from the lattice. The electron is therefore transferred from sodium to chlorine. The crystal lattice structure of ionic compounds. Ionic substances are actually a combination of lots of ions bonded together into a giant molecule. The arrangement of ions in a regular geometric structure is called a crystal lattice. So in fact, sodium chloride does not contain one sodium and one chloride ion, but rather a lot of these two ions arranged in a crystal lattice, where the ratio of sodium to chloride ions is 1 to 1. For example, the structure of the crystal lattice is shown on the screen. Properties of ionic substances. They are actually crystalline solids because their oppositely charged ions attract one another strongly and form a regular crystal structure. 2. Flat sides and regular shapes because the ions are arranged in straight rows in a pattern. 3. Melting and boiling points are very high because strong ions bond between cations and anions. A large amount of energy is required to separate the ions. Example, sodium chloride melts at 808 degrees Celsius and boils at 1465 degrees Celsius. 4. Low volatility because there are strong ion bonds between the ions. 5. Solid ionic compounds don't conduct electricity because the ions can't move. There are no free charge carriers. 6. Molten or dissolved ionic compounds conduct electricity because in their situations, the ions can move and carry charge, which allows current to flow. 7. They are usually soluble in water because insoluble in organic solvents. 8. They conduct electricity when dissolved in water or when melted. Ionic compounds are made up of ions but do not conduct electricity in solid state because ions are held together by strong electrostatic forces and cannot move freely. When we dissolve ionic compounds in water, the structure is broken and ions become free to move and conduct electricity. Metallic bonding. These are formed when the valence electrons of metal atoms are shared by more than one neighboring atom. The metal atoms are held together by a sea of electrons floating around. Metals consist of a lattice of positive ions through which a cloud of electrons moves. The positive ions will tend to repel one another, but are held together by the negatively charged electron cloud. The mobile electrons, known as conduction electrons, can transfer thermal vibration from one part of the structure to another, therefore meaning that metals can conduct heat. They are good conductors of electricity. Properties of metallic substances. The sea of delocalized electrons are tightly packed metal kernels, are responsible for the properties of metals. They have high density, good conductors of electricity. The delocalized electrons are free to move randomly throughout the metal, but if a cell is connected across the terminals, the electrons will drift towards the positive end. They have good conductors of heat. Decolorized electrons can also transfer heat energy from a region of high temperature to a region of low temperature because they move so freely. Metals have high melting and boiling points because of the strength of the metallic bond. Metals are malleable and ductile. They can be easily flattened, shaped, or drawn into threads without breaking. This is because the metal kernels are not attracted to one specific electron. This makes them different from an ionic compound, which is brittle. Metallic luster. The sea of electrons would reflect all frequencies of light to give a shiny surface. Physical change. 1. Usually easy to reverse. 2. No new substances formed. 3. Small energy changes involved. 4. Melting, evaporation, separation of mixtures. The particles stay the same, but their arrangement changes. Example of physical change, water. The particles change because the bonding between their atoms change. Consider liquid water evaporating to form water vapor. Each water molecule consists of one oxygen atom bounded to two hydrogen atoms. During evaporation, the actual water molecules do not change. The mass of water and the number of molecules does not change. Energy is absorbed to overcome the forces between the molecules. This changes their arrangements and movement. This change could be represented as follows. Chemical change. 1. Usually hard to reverse. 2. New substances formed. 3. Large energy changes involved. 4. Decomposition, synthesis, burning, rotting, rusting. The particles stay the same but their arrangement changes. Example, decomposition of hydrogen peroxide. These two reactions are chemical changes because new substances are formed. Huge energy changes are involved. The bonds between the atoms of the reactants are broken and new bonds are formed to create the molecules of the products. Every atom in the reactants becomes an atom in the products. The mass is conserved, but the atoms have been rearranged.